Now, in the last class, we are discussing about the KNN, now K nearest neighbor. Now, today we will also discuss this K nearest neighbor. After that, we will move to the other part. Now, in the K nearest neighbor, I had also discussed the nearest neighbor cluster analysis, the mean value, and so on. Right. So I would also discuss the misclassification in the last class too. So, did I discuss the classification error in the last class? Did I discuss it? The classification error?
No, sir.
So I had discussed the misclassification. Did I discuss the misclassification?
Yes, sir.
Uh, Now suppose these are the data points. And, and these data points are belonging to a class. Suppose this is a rate class. There are other data points. These data points are also belonging to another class called blue class. Now, this point, and suppose this point, these 2 points are basically the mean value, of the red class, of the class red. And this point is also the mean value of the blue class. If there are data points lies between this red class and the blue class, so these data points are explicitly classified to a certain class. And these data points are also explicitly classified to another class. These data points belonging to a class red, these data points belonging to the class blue. The middle point is basically the mean value of the red class, and the mean data point, this data point is basically the mean value of the blue class. Now, if there are points lies in between these two classes, so there are few, now these points are not classified, right? So these data points are not classified. So this, but most of them should be correctly classified. The points belonging to the red class, the points belong to the red class because the distance between the red class is same as the distance between the blue class. So it may sometimes happen that the red class may extend in order of the circle to encircle the data points, and the blue class may also extend. So if I extend to the blue class, right, uh, blue class or encircle these data points, they are wrongly classified because these data points neither belonging to the blue class, neither belonging to the red class. So these data points are basically the misclassification or misclassified because these data points are does not belong to any of the two classes. So they are misclassified, right? So so these data points basically creates the classification error, right? Because they are not classified, they are not distinctly classified between the two classes. Now, it may happen sometimes that the points belong to the red class and the points belong to the blue class may may have the same distance. The distance between the data points belonging to the red class and the data points belonging to the blue class are belongs to the same distance. So in that case, we may encircle the data points, the blue class. Also, we may encircle the data points which with the red class, but it is not actually that actually true. Therefore, it is wrongly classified. right? Let us, if I say that if the data point, let us suppose the point P prime, if I say the point P prime falls in the blue class, which actually may lies in the red class. So there also creates a misclassification. So, so here misclassification occurs because the mean value of the red class is calculated by calculating all the data points of the red class, and the mean value of blue class is calculated by calculating all the data points of the blue class. Hence, when the newly marked point P prime must belong to either of the red class, because the mean value of the red class is calculated by calculating all the data points of the red class, and the mean value of the blue class is also calculated by calculating all the data points of the blue class. So it may create a classification. So classification errors basically occurs in three stages. I here we take the data points which are belonging to the red class. We take the data points which are belonging to blue class. We calculated the mean value of the red class and the mean value of the blue class by calculating by considering all the data points of the red class, and considering all the data points of the red class, we calculated the mean value of this point. By calculating all the data points of the blue class, we calculated the mean value of this blue class. Now, if the data points lies between the red class and the blue class, then these data points are neither belonging to the red class and neither belonging to blue class. So these data points are misclassified, number one. Number two, there may be a data points which falls in the blue class, but it actually lies in the red class. So it also creates a misclassification because that data points actually lies in the red class, and the mean value of the data point is calculated by calculating all the data points of the red class. So that data points cannot fall in the blue class. So if that falls in the blue class, if any red class point, if any of the data points of the red class falls in the blue class, then it again creates a misclassification, right? Right. So, uh, and number three is if the points belong to the red class and the point belongs to the blue class are at the same distance, So it may happen that the red class we can extend the red class point, and we may again extend the blue class to encircle those data points, but that means that data points are wrongly classified. So it also creates a classification. So classification error takes place in three stages. If the data points lies an intermediate position of the two classes, it creates uh, it creates a misclassification. If the data point belongs to the red class, falls in the blue class, it creates a misclassification. And if the data points are of the red class and the blue class are belongs to are at the same distance, then we have to extend the red class and or either of the red class or either of the blue class, which is not possible and which may create a classification. So these are which again another property of misclassification or misclassification may occur. So in this way, so in these three stages, the misclassification may occur, right? Have you got it?
Yes, sir.
So the classification error, sometimes it may happen that there is classification error. Classification error may create the conflict between the two classes. Conflict between the two classes. We can find now how these conflicts takes place. These conflicts takes place when one class of data point falls on the other class of data point. So it is very rare cases, but it may occur, and then only that conflicts can occur. So this in this type of conflict, the KNN algorithm is used, and which can be this conflict can be avoided by this KNN algorithm, and we need a nonlinear classifier which can perform but better than KNN, that is naive based classifier and so on, which can perform better than KNN for to remove this conflict. But uh, so this there may chance occurs of the data conflict takes place when one data points of one class falls into another class. So that creates also, I had told earlier that that creates some misclassification. No. Is it visible to you, this article? This article is visible? Is it visible? This article is visible.
Yes, sir. No, it's not visible.
Yes. No. Suppose we have to take the data set from we have to download this data set. So in this article, we have to import this numpys and pandas, and for pyplot, matplotlib, this plot we have to write for the graphical application. Now from this URL, we we will get this data set. We will import from this, and the pandas will read this CSV file into the data set. Now we after getting there by using the property head in the data set, we will get this data set in this form. The first 5 figures will be displayed. Now for pre-processing, here we are going to create the machine that is developing an algorithm, right? So here we have the 4 predictor variables, 4 predictor variables, and 1 target variable. So we are and 1 target variable. So the target variables are the 3 of the 3 classes. The 3 classes will classify these given data points, which is given in this scatter diagram that I discussed earlier. This. So from here we are taking x and y. So x is the y is the target variable, x is the predictor variable, taking consideration of the whole data set, and which is defined by this values, and y is also taking the consideration of the whole data set. And since there are 4 predictor variables, therefore we write 4 over here. Now, after this, we are training the data set and testing the data set, that is splitting the data set into train test and training the model and testing the model. Now, training data set means for building the model and then evaluating the data set we use in testing the model. And that is why we are from scikit-learn model, from a scikit-learn model selection, we imported this train test and then splitting this model into train test and the test set, keeping on consideration that our test set will be 20% and our training data set will be 80%. So out of 150 records, the training will be 120 and testing will be 30. So now features and scaling. Now so much, if we want the accuracy of the model, we have to use more features, and at the same time we must scaling those features. So here training set is used to, as we know that it is used for building the model, and after learning this data it can be understand that the data and if it can if we apply the test set which is new to the model, it can easily predict the new data set, right? So training the data set is used for building the model, and after learning the data it can understand that if we apply the test set which is new to the model, it can easily predict the new model of the data set. So before making the actual prediction, it is always a good practice to scale the features so that all of them can be uniformly evaluated. Right. So scaling is very important so that they can be uniformly evaluated. So here we are converting our data distribution into an uniform distribution classification. Right. So after that, we for pre-processing, we use this sklearn's pre-processing. We import this standard scalar. Then we are fitting the model. Then we are training the model and we fit the model into the scalar. So from sklearn.neighbors, we again import the k-neighbor classifier, and suppose our nearest neighbor is 5. We take this as a k-neighbor class. The first step, we have to import the k-neighbor classifier and the from the sklearn library, and then we have to initialize one parameters, that is the n-neighbor. We initialize it as 5. This is, that means the value of k is 5. If we can initialize it with 3, that is the value of k is 3. So we start with 5, that it seems that most commonly used values of KNN algorithm. Not only that, we can use the commonly known KNN algorithm is 5, is 3, 5, 7, and so on. So we just initialize this nearest neighbor. Suppose there are 5 nearest neighbors, so we initialize it as 5, and then we fitting this training set into the classifier model, that is the KNN classifier model. And after that, we are predicting that model using the X test set. From there, we go to the metrics from the classification, and from classification report and confusion metrics, we get the output result. This is the confusion matrix of the KNN classifier using the 5 nearest neighbor, and from there we get the corresponding precision, recall, and F1 score. So the result shows that our KNN algorithm was able to classify 30 records in the test set with 100% accuracy, precision. So the accuracy is 100%. That means our classification is excellent. See, the precision is 1, and the recall is also 1. F1 score is 1. So the classification is 100%, 100% accurately classified. Then we compare this error rate with the k value. In training and prediction section, we see that there is no way to know beforehand which the value of k that yields the best result in the first go. So we randomly choose 5 as the k value, and which after choosing this 5, k is equal to 5, we see that the result is 100% accurate. So one way to help you to find the best value of k is to plot the graph of the k value and the corresponding error rate of the dataset. So this is obviously uh, is also implied when we are when we are evaluating the algorithm. So in this section, we will plot mean error for the predicted values of test set, of for all k values between 1 to 40. So we will plot the different errors from the predicted values and between which ranges from 1 to 40, and after that let us first calculate the mean error value for all predicted variables and where k ranges from 1 to 40, and we executing the following script. So we are calculating the errors, so we define error as the first, and we start a for loop starting from 1 to 40. The k nearest neighbor classifier will calculate all these errors and for both the predicted values, and this error will be appended. So the above script executes the loop from 1 to 40. In each iteration, the mean error for the predicted values of test set is calculated and the result is appended in the error list. So every mean error is predicted and it's calculated and the result is stored in the error list. So the error result is stored in the error list means that is in the error queue. This one. So we plot the figures from 1 to 40 and we are labeling it as the error rate values. So from the output, we can see that the mean error is 0. The mean error is 0 when the value of k is 5. You see, for 5 nearest neighbor, or when the value of k is 5, the error is 0. Between when the value of k is 5 to 18, right? So 5 to 18, the error is 0. So from 5 to 18, there is no error. And again from 26, 24 to 29, there is no error. After that, the error reveals. There are many errors. So between 20 to 25, 29, 24 to 29, there is no error. And from 5 to 15, there is no error. So our classification is rightly classified and it shows that our model is rightly classified. So KNN is a simple and a powerful classification algorithm. It requires no training for making prediction, which is typically one of the most difficult parts of the machine learning algorithm. The KNN algorithm widely used to find document severe pattern recognition. It is employed in developing recommender system, dimensionality reduction, pre-processing steps of computer vision, particularly interesting. So these are basically the applications where the KNN right, for speech recognition, and the KNN is also used for face recognition tasks. The KNN can be used. So these are the basically the applications area, the real-time application area where the supervised classification model can be used. So that's all from the KNN. Have you got it? The algorithm?
Yes.
So we have completed this KNN algorithm. In the next class, we will proceed to the decision tree and the random forest.
So still how many days we have the training?
We will complete it by we will try to complete in the last class, and if it not, then we will take another class. So at most there will be 2 classes. By 2 classes we will stop the training.
By next week we'll get complete.
Yes, yes.
Okay,
Fine.
thank
So any problem you can ask. So we will stop over here.